Hey, Mr. Tyler.
All right, so get your screens ready, Autumn, and get started in a moment. Trying to get students about 3 more minutes. I just did attendance. Now I gotta reverse it because you're here. Let's see here. Somebody else is coming into the classroom. Who is this? That thing is loud. It felt like a doorbell. Jalen. Okay, that's who it is. Welcome to class, dude. All right. Y'all making it before the buzzer, I see. So we got a lot to cover. This is a review problem, but this is that long problem from last week. So you can save yourself a lot of trouble if you just pull the notes from your notes. And what I mean by that is pull the notes from your Google Drive. That's the way I meant to say it. Sorry about that. So 2 minutes, we're going to begin our norms. And go back and put Jalen in now. So this is fifth period. Um, okay, so I got Stucky's present, Hall is present, Autumn Hall. Paris Hall is not here. All right. Okay, let's recycle and get this ready to send to the office. What are people doing? They didn't come to classes today. Nobody's sick or nothing. Okay, something froze on me. Let's check this again. Okay, I got Autumn and I got Jalen. Good. Okay, I wanted to make sure I did it right. Okay, so 1 minute and then the norms. I think the norms should be over here already. Let me see here. I think I got, yeah, I got my norms. So I think I did that. Where'd that clock go before it starts ringing? Found you. All right. All right. Get the people list going and I can see your cameras. All right. Everybody else, let's check this out. Let's do this. Oh, that didn't change. Okay. Okay. Let's stop that. Let's turn this off. There we go. Now, okay. So now, let's move this out the way. And it's only two of you guys until somebody else comes in the room. Autumn, can you read the five basic norms on the screen?
No one has the right to hurt another person. Education and the classroom are sacred. We will never behave in a way that will discredit ourselves, our school, or our family. At Excel Academy in Southwest, student is always a lady or a gentleman. We take pride in Excel Academy at Southwest.
All right, thanks. Okay, so next is Jalen. I'm gonna need you to read the five academic norms. Are you able to see it on the screen?
Yeah. We respect the opinions of others. We respect the culture of the classroom. We are attentive and participate. We have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing ourselves for post-secondary endeavors.
Thank you, sir. All right, so let's get started with today's assignments. Fifth period. Pretty sure people are going to start coming in the classroom. I spoke up the devil. Look at this. I said, I'm pretty sure people going to start coming in, and there's Miss Kennard. Hey, Miss Kennard. Let me see here. Let me mark her present. Uh, Kennard, there she is. All right. So everybody should be getting their screen sized up. Want to try and get this attendance corrected. And what I mean by screen sized up, you want to have your screens. Make sure on because I know a lot of you guys are on laptops. So I thought about this and remind me, engineering school, have a window so you can be multitasking, right? Because at the very end, we're going to be creating one more simulation. And on top of that, this technique is going to help you on Friday because you have to have simulations for each problem, meaning each problem had a simulation we did. So you got to go back and make sure you do that again. If you don't have those snapshots, you got to do the simulation. So we got to get used to that. But let's jump into this problem because this thing is enormous. And I'm going to put the notes in sections, but you have to edit the same way because I'm going to try to feed the notes to you in the chat. But the problem is the chat is not going to format it the same way. So it's tedious because you have to go back and edit everything. The students in last period, they were frustrated. But if you take your time and do this, it'll help your scores. And like what, next week we got finals. So we're almost out of here. Besides, October's gone, right? Does anybody plan on going trick-or-treating or no?
No, I don't like Halloween.
Okay. I'm seeing how smart y'all gonna be about that. With COVID out there, run around. I don't know. What about you, Autumn? You gonna go trick-or-treating? Oh, she's gonna look at me. All right, that's cool. That's cool.
No,
Oh, okay. I figured
I
that's
was
what it
trying to
was.
go back to the other screen, Tyler.
Oh, okay. You busy. And Miss Kennard's eating, so I'm gonna leave her alone. All right, so let me get into today's assignment, right? We're gonna go to a blank document, and what we want to do is make sure we're in the Gmail account we're going to use. So in my case, it's this one. And next, we're going to go to the docs. And what we're going to do here is go to blank document. Okay. And what I want is to start, you can double click on this, but let me expand it so you can see it. You're going to open this up and you're going to do the do now, right? That's the title. Dash in today's date. That's on like October. Where did it go? 10th. I'm just starting your document off with you guys. That's all I'm doing so far. We haven't even done a problem yet. Somebody's coming into the room. So you guys try to fill in a little bit more. I'm trying to see who's walking in the room. Sherrod Perry, welcome to class. Okay. As soon as I heard that bell, I was like, I got to stop and do the attendance because I almost didn't do the attendance the other day and I got on my nerves. To go back and watch the video and do the attendance over again. That was so sad. All right, so Perry's present. Okay, I think that's saved correctly. I'm gonna come back to it. So we was just establishing the document, Mr. Perry. So try to catch up. So we're gonna zoom in to 150%. So you can see. And the next thing is, of course, what? That's gonna be our header. If you remember, right? So that's what's inside of the header. Well, first and foremost, it's gonna be your name, and then it's gonna be the date again. So it's 28th of October. And it is 2020. All right. Period is going to be, it was the last period today, right? Woo, we made it to the finish line yet another day together. All right. Engineering with robotics. Close parentheses, come down a few steps, and then you put in the title. Now, chat's disabled because we had some people jumping around. I open the chat every now and then to give points, but it's not going to stay open no more, right? So you just got to kind of help you. I'll still post some notes here and there, but you guys are not able to respond that way no more. And then share outs will be at the very end. I just hope you know it's worth 45 points towards your grade when that share out moment comes towards the end of class. So I hope you're typing with me. Some students today have said, well, I just deleted it. I don't know. I'm like, well, I just deleted 45 points if you're in class score. So no, you should do better about that. Title, go back to ESB. And what do we got? Well, for in ESB, you're going to see the Facebook drawing. As Mr. Porter said, get that free money. I almost said bread. Get that bread is what he said, but get that free money because you do is just go and follow the directions on the flyer, right? If there's 80 people that end up following our page, that gives somebody opportunity to get $200 at least. So just takes you sharing it and also doing the directions. These links here, just wanted to make sure you know, are links to get to your classroom or townhouse. Townhouse has not changed, the same link. And also this is a link to get to the class today. Now, today's problem, let's go through it because I think we've established it. And I'm slowing down here because I was asking about the title. Well, you wouldn't know about the title unless you're in ESB. Copy this. and come over to the chat. And here we are. Okay. So there you have it. I want Mr. Perry just came in. He hasn't done something yet. Can you read from hello down to resistor, Mr. Perry? Did he hear me or no? All right. I think he didn't hear me. So, Miss Kennard, could you read from hello to resistor? It's worth 25 points. You can't? Oh, you chewing. Okay. I just, okay.
Sync the S in the one S.
Start from hello.
Hello, all future electrical engineers. As synchronous problems need to be completed and ready to present tomorrow in class. A. Asynchronous problems have to be completed as homework and will be checked tomorrow in class as well. One as a circuit consists of 3 resistors in series to a 24.6-volt battery. The current in the circuit is 0.0327 amps. Given that R1 equals 255.2 ohms and R2 equals 157.8 ohms, find A, the resistance of R3, and B, the potential difference across each resistor.
Wow, well read. Thank you, Miss Kennard. Okay. She read that real quick. So 25 points for her. Let's go on to the second part, which is understanding what's expected of you when you do this assignment. So I'm going to bounce over to Mr. Stuckey. Can you read what's in the chat? Did I put it there? Not yet. Hold on. All right. Can you read that for me, sir? Starting from please on down to Zen.
Yeah. Please remember to get maximum credit. All calculations, steps for the final answers to the problem need to be uploaded to SBP, the same format that we have been using since the start of the recording. This format is shown in the video. Type dot converted to PDF. Stay safe out there and Zen.
Awesome. Awesome. All right. So that gives you an idea. Like you guys turn in for maximum credit. There are things like your exit slip. That's maximum credit. It's adding to the original score. You got the steps. You have students cutting corners. They're not putting all the steps. They're not finishing the problem off. These things hurt your score. So just finish the problem out and, do your due diligence so you don't have to come back and be like, Tyler, what my grade look like? Well, why your work look like? And that's going to be my argument. And I don't want you to, have a bad day on that. So let's jump into it further. We're going to take the questions, right? There's 2 questions. One is the synchronous problem. We're going to do that today. But there is a synchronous and asynchronous schedule. I'm not sure if you guys are aware, but you'll be seeing this pop up a lot. There are going to be days where you can work with me. Like tomorrow, you'll be able to work on prior assignments and catch up because this is the synchronous days for robotics students. So that would be 3rd and 4th period robotics students. You would come into class tomorrow and it won't necessarily be a do now or assignment. It'll be, let's work on something we didn't do from the past as a class, right? So these are like days to help you out and get stuff done. All right. So be expecting that tomorrow. And we'll talk about that again tomorrow because when you come in, that's what's going to happen. And that's for all classes. Each teacher should be giving you synchronous time to finish up on your assignments. And that's time where they're in the room and they're helping you, not necessarily teaching, but helping you do the problem. Okay. So take advantage of that because I think they're going to roll this all the way out to quarter 2 and 3 and 4. Now, here's the first question we want to take from Edsby. All right. It's the one that was just read by Ms. Kennard. So come down a couple and put the question there, but something goes before it, right? The title. The title of today's is the 3 resistors in series, and its equivalent resistance is your classroom term. So it's called 3 resistors in series, right? We're gonna center this. All right, somebody's coming in the room. You guys want to put your exit slip next. Let me see what this is. Oh, it's Miss Vega. Okay. So you might want to put your exit slip above, right? I was like, who is that? So the exit slip earlier, yeah, I could take it from here. Is here. kind of doing something to work for you because it's taking it from last class period. But this is how you should set your exit slip up. So I'm going to give it to the chat to give you guys a head start because we still have a simulation, and this is the part that took some time for some students. So you are okay. So in the chat, I have a formula. I mean, not the formula, the format for how you would get your exit slip typed up. I even gave it to you. So if you have that bit, that's 25 points. Now, I did this way because it's a perfect example of how you should have done the exit slip. So I need, let's see, Mr. Perry, are you able to respond now? Can you read what is in the chat for exit slip? Okay, I guess he can't hear. All right, Autumn, can you read that?
Exit slip is worth 25 points. Classroom term of the day is equivalent resistance. Practical capacitors and inductors as used in electric circuits and not ideal components with only capacience or inductance.
Mm-hmm.
Inductance. Word of the day is ignominious,
Close. Keep going.
deserving, or causing public disgrace or shame.
Okay, cool. Thank you, Autumn. That was 20 points. And that's what you would have to put to get the exit slip completed, right? The way I have it set up now. All right, so I'm going to keep going down, and next are the steps. But before we do that, we need to visualize what we're doing, and this is the simulation part. So if you give me a moment, I'm going to give you guys the simulation link. Now, it's listed here in this classroom I keep giving you guys, but I don't think you pay attention to, because if you don't have the simulation link or you remember what it was, you can always come here and come back to it in case you need to do it later. You didn't have time to do the simulation. So inside of your ESB, I have a lot of things on your timeline. They're chronologically down. So from that day past is how chronologically down works. In your recordings, always leave the link. So it says this recording here, you see .google or DLC for documents. And this link you can use to get through. So you can get this from ESB, or you can use it in the chat real quick. All right. And to get to the simulation, you click on myself. After you clicked on that, let me move this out the way. You click on me sitting on the couch. And then if you click on the physics classroom here, right, this SPS logo, it'll take you to the physics demonstrations booth, which is what I call it. There's this circuit right here. You're going to click on it. Everybody see what I'm pointing at? Did everybody get to this slide? So do you need me to do what I did again at the beginning? I click on myself, click on physics, which is this here, and then I click on this icon here, because this is for circuit analysis. When you do that, this will show as shown. It's loading and loading. So do this now, because we're going into the lab component this week, and we're going to do a blueprint of what we did last week. So last week we did the cartoon version. This week we're going to do an actual blueprint. And the blueprint button, when you get in there, is this one here. This is the cartoon version. This is the blueprint version. So if you guys get hired as HVAC technicians, engineers, electricians, you're not going to see the cartoon version. You're going to see a blueprint. And these are some of the icons for each thing we've worked on. So come here for a second, because I'm about to start setting this circuit up. You need to be doing this with me. All right, so first thing I'm gonna grab is a battery, right? And put the battery here. I'm gonna grab a wire. I'm connect the wire, and I'm just gonna put a wire to each end of the battery. Okay, I hope everybody's seeing what I'm doing. Next, you're gonna take another wire, because we're making a series circuit. We talked about series circuits last week. I wish we had time, we can go into parallel circuits, but we're gonna make a small parallel circuit. So you're gonna take a resistor now, And that was the resistance part that was read in the problem. This is a resistor, or a cartoon version of it. You have this all over in the house with electricity. So many resistors everywhere to regulate the current flow. The little blue icons that have the lines in the middle, those are electrons. That's how current flows, right? They're in the wire, the resistor. They're also in the battery, if you see it. So grab another resistor. So this is my second resistor. This represents the resistors you saw in the problem or read about in the problem. So just another wire. And you have to set this up the same way as me too to make it work. So I hope you're paying attention. I'll take a resistor and I'm connect here, and then we'll follow up with one more wire. And if it works, you'll see the electrons travel in that manner, right? Now, you need to turn on the values. Okay. See, that's 10 ohms. This is a symbol for ohms we was talking about last week in this calculation. So each of these resistors are ohms, and that's 9 volts for a battery. All right, so we're going to use some tools. But right now we need to put a load onto here. We need to use this system or this circuit to power something. The reason you got the resistors in place is because if you have a 10 ohm bulb, you don't want the bulb to blow out. Most bulbs, they have like a fuse breaker. So now we created what is called a series circuit. It's in a loop. All right, and you guys should be doing this with me if you went to the simulation. And we're going to connect it just like this. We're making a parallel circuit, which we'll learn about maybe on Monday or Wednesday. So I think we're off one of those days. We connect this here, and you notice the bulb has 2 connection points. Connect them to the right points, and the bulb turns on. Now, what's the best way to make these electrons go through the circuit faster? Anybody know? You can turn your microphone on and tell me. Well, one thing is we could increase the voltage, right? So if we go over to this battery and we click on the battery, you can flip the polarization of the battery, or you just turn the voltage up. And in our problem, I think the voltage was like 25 or something, 24. Let's go back to the problem for a second. So it's about 24.6 volts. So let's try to get the battery to 25 volts, and let's see what happens with our light bulb. You see these are the rays of light around the bulb, and I only got it at 9 volts. Right? So change yours to 25 real quick if you can, because that's what I'm about to change mine to. Your battery. All right, so what did I say? 24? It was 25, right? Because it's 24.6. I'm just going to round to 25. And yeah, be careful with the dial. It's best if you have a mouse. So I'm going to leave mine at 25.5. As close as I'm going to get it. And far as your resistors, I think it goes as high as, you can click on the resistors, 120 each. So the biggest resistor we have in the bunch is like a 175. So don't worry about that. Just leave each resistor at around 10 to 20 ohms, okay? And I do want you to just change the colors of these resistor bands a little bit, because when you are a technician or you're working on these things, you won't know what the resistor is until you know how to calculate what each color means, so you know how much resistance is on it. Notice the different numbers correspond to different bands of colors. All right, so I think that's pretty much it. And you also see the resistors affect the rays of light. Like if I increase it 25, the rays came out. But if I increase this resistance some more, you'll either see the rays die out, right, or come together. Okay, so I think that's good. Next, we're going to need our tools, and we're going to take a snapshot. And then we're going to do this problem. I'm going to give you guys notes on what we reviewed last week, because it's the same problem with different numbers. So I want to see how much voltage is coming off of this light bulb. So I'm going to take my red lead. I'm going to connect it to this first junction point, right? So to do that, to make it easier, guys, I said you can do it here. We're going to take the other lead, which is the black lead, and we connect it here. So it says that between here and here around this bulb, you get about 5.09 volts. Okay, this is an important technique, especially if you're measuring voltages on a battery of a car, or you're trying to find how much juice you got in the car's battery, or you're trying to replace a light fixture like a ceiling fan. That is important to know if you're using this tool. So that's a voltmeter. And the last tool we're going to introduce in here is an ammeter or a current meter. So they have this type, this is an expensive type I've seen at Menards. This is an even cheaper version. So we're going to use the real simple version that you can pick up at a hardware store, and it's called an ammeter. So now I just got to disconnect. So I'm disconnected, right? And what you have to do with an ammeter is you have to connect it into the circuit. Okay. So I'm gonna connect that back, but we're gonna get one more wire and connect this current meter into the original circuit. So now we know, if you can do this, how much current you're getting across that light bulb too. Let's put that lead back so you have the voltage around this. And the voltage drops could be different. You connect it here, it's 5.9. You connect it here, it's nothing. So connect it correctly so you know how much voltage is coming out the light bulb. All right, so it's 3:08 and we still got notes to do. I want to give you guys about 3 minutes, and then we're going to go through the notes of this problem, and there are a lot. But when you're done, and you got to set up the same way as me, you're going to click on the FET in the corner and make sure you take a screenshot. All right, you click on screenshot, it'll download over here. Make sure your values are on like I have over here. And before you take a screenshot, make sure it's in the blueprint form. Okay? So take the screenshot, like I just showed you how, but this is the final snapshot you're going to need. And you're going to do it correctly, so take your time with it. You can get close to these values, but I don't know if you just copied it from my screen and did it. You have to do it because there's a watermark stamp. You guys have to be logged in as users because that data comes back to, I think, Colorado Boulder, and they let me know what's going on, like how many students were using it. All right, so once you get your snapshot, you're going to come back to your Google Doc, right? And this is the picture I was telling you we had to generate, our simulation. So to put the picture in that you just made, you just hit Insert, Image, and you come to Upload from Computer. Now, if you screenshot it already, you should be able to find it easily. Come over here to the picture. You see it's this one with the blueprint. Hit Open, and there it is. Okay, so let me go back so you can see exactly what you have to set up. Okay, and give you about 3 minutes to catch up with that, because we have effectively we got 30 more minutes of class, and we got a lot of notes we had to put into our Google Doc.
Do we take pictures of this one with the just mine, so with the battery on?
Just this one, the blueprint version, my kid. Is that what you're asking?
Okay.
Okay.
Yeah.
Okay, so you guys cool? Kind of start the notes now or no? Did everybody get the screenshot at least? That was the one that takes the longest time for people because by the time I figured when I do the steps, then have you do the screenshot, people be having trouble. So I was trying to give enough time to get that out the way. Was everybody able to get the screenshot into the document? So I'm talking about what I did here on the screen and what I showed you how to set up your blueprint version, not the cartoon version, the blueprint version of this circuit that I just created. You should have built it the same way and have these tools on there too. All right, well, I'm assuming everybody has that. So let's go back to, what we have to take care of, which is how to calculate the problem or how to solve the problem. So we read this problem a moment ago. And that's why I made if you took a look at the picture, I made my calculation or my battery, which is, what it's connected to, 24.6 volt battery. I just ran to 25, and that's what I put here. Okay. And then next, if I scroll up a little bit, the resistors. There's 3 resistors. I just made them different resistors. And this is not necessarily the third resistor. We have to calculate that. All right. So here are a lot of initial notes we got to go through to do this. So hold on for a second, because I'm still trying to do this and give you guys the overall big picture of what happens here. So these are notes from last, Wednesday, I think, because today's Wednesday. So last Wednesday we covered this material. And yes, before you ask me, you gonna put that in the chat? Yes, I am. But I want to make sure you understand how to at least edit it correctly. So this is what it looks like on the screen, if you can see it. So I'm gonna go through. That's what 200%. And move this out the way. And this is your initial notes, and this is how it has to look. Okay. So let me put it in the chat. And notice when I put it in the chat, it's not going to come out as clean. All right. So it still has to be centered in the middle of your document. And this is after the picture, everybody, too, by the way. So make sure you put it in the right place. All right. So now I'm going to come down here and make sure the rest is there. There's also a part about Ohm's law and how it's edited. Okay. All right. So let me keep going. I want to at least get your known and unknowns, and then have a share out to see how far you guys have gotten. So where's that part at? And again, this is a problem from the past. Miss Kennard left, but she's here. How did that work? Okay, I don't know. Maybe she had a different thing logged in. The notes. The screen just jumped. Like, okay, she just left. No, she isn't. She's right there. So let's grab our voltage drops at least, because there's 3 of them. And that's in part B, everybody. So let's come here. And if you're not sure what I'm talking about, again, you can type this up in your Google Drive. And all of you should have these notes from the past, right? Oh, this is not supposed to be there. I cut in between it and move this back upstairs. You know how it's supposed to look. So this up here is supposed to go, this part that jumped in between, I didn't know it was underneath it. Goes here. Now that's better. Okay, so let's recap, right? I'm gonna zoom out so you can see majority of what happened. And put this in the chat before I forget. So no, that's the same thing. I had to make sure it was the right thing that copied, and it wasn't. So I'm talking about this. Perry left. Oh, people leaving early. I hope he comes back. All right, so copy, and we're gonna put that here. And there we go. So look how the chat does it. It's all jumbled, huh? So take a look at what I've did so you understand what is going on here. This symbol here is for the battery. That's your voltage. This is I for current, right? And notice there's a lot of editing you got to do. Yours will come across as R1, and that's not the way you write R1. All right, so I'm gonna blow up. What is this? Is this font 10 or no? That's 14. It's already big. All right, so I'm gonna come down to 150. How about that? That helps us. 200, which is all. Well, I guess I gotta keep it at 200 because I'm looking at the monitor screen and it looks better for you guys. All right, so I want to give you about, I don't know, another 2 3 minutes to get this edited correct because I'm looking at the chat and I'm telling you, it's not going to get you credit to just copy and paste it. You got to make it the same way I have it. So R3 is subscripted. Most of the numbers by the letters, if they come down just a little bit, it's called subscript. You can find subscript by going to format text, and it's this option here. Okay. Don't get points knocked off because you didn't do the small things. This symbol, omega, if you need to create it and use it, go to insert. Same thing with this symbol here, or delta, the ones we talked about. Because if you notice in the notes, I'm not using the word ohms anymore because I don't want you to get confused with Ohm's law. I said earlier last week, use this equation, which is the actual mathematical way of doing it. You guys are applied physicists. That's all an engineer is. So let's keep going. There's a part A and part B, and there's a lot of notes to that. So first, take a moment and make sure you correct these things because it's not V3, it's V subscript 3. It's not V2, it's V subscript 2. I know it sounds like I'm being petty, but honestly, my name goes in your transcripts with you. You gotta make sure you did things right so it don't look bad on me or you. So just do that part and you get maximum credit. All right, so I think I've said enough about that. I want to get to the steps and the strategies. So I think I'm gonna post a strategy so you can see how tedious it is. Give you about a few minutes to get that because it's 3:21, and we got at 3:40. I was hoping we can get out at maybe 3:35, but I'm pushing it because it's a lot more notes that we got to get into this. And don't forget, these notes help you complete the asynchronous or homework problem. Okay. So take great notes because they're going to help you. The problem's identical. That's why I say it's going to help you. You just got to try it out. Okay, so where's the next section? Not cursor. So I think it's the French call it a cursor. So undo, and I'm gonna come down one, and now you need the strategy for solving this. So what we do now is we use Ohm's law, and we talked about Ohm's law a moment ago. It's that's the equation that it says V equals IR, right? So we had to first figure out what REQ is because the problem's asking us to figure out how to, where is it at? How to get R3. Let me scroll up for you guys so you see it. So you try to get R3 is the biggest thing. Okay, so right here it says find A, the resistance of R3. B, the potential difference. That's the voltage drops. Just like we took our voltmeter and connected this to this, that's a voltage drop. So and this is Ohm's law again in case you forgot. The equation simply is, it doesn't say it there, is V equals IR, right? Or I times R. All right. So that's basically that one. And don't forget, R is still ohms, but you use omega. So let me come here. Put this here for you. And we're going to grab all of the steps necessary for this problem. So first things first, let's grab this. Put that here. And here's the steps. We're going to do some algebra. This is what we were talking about last time. So the strategy is use Ohm's law, right? And put this in the chat for you guys. I was really talking through it to slow down and make sure you had time to collect the notes. So welcome back, Mr. Perry.
I lagged out.
You lagged out? What happened?
I lagged out.
Oh, okay. Well, you're back, man. All right. So your goal is going to have to be, I think I put in the chat what you need to make sure this doesn't say ohms, right? I'm going to tell you all the ohms values afterwards have to have that symbol. So you highlight ohms, you go to insert, and then come down to special characters. Click on arrows, change it to math. Once you do that, you will type the Greek letter called omega. And it should give you this symbol here, which is what we use for ohms. Okay? They'll do the same thing for that next ohms, but once you got the symbol in there, you can also copy it and highlight what you want and change it by pasting it. This is essentially how you have to edit your document, right? Okay, so I'm going to slow down for a second because it's 3:24. We got a few more notes to go through because we got to get R3 and then we got to get all the voltage drops. So take your time on this. All that happened here is, remember, when it's in the chat, it doesn't look right because volts are crossed out with amps. Ohms is here. And then, you got something crossed out here. If you look in the chat, it's a double line and you won't know that that's going to get some points knocked off because I do pay attention to detail and I do make sure you do it correctly. So let's give you about, what can I give you, 2 minutes to get caught up. And you're just going to take what I gave you in the chat and try to edit it into your Google Doc. Okay? Tomorrow, again, I think it's going to be asynchronous time for you guys. So I'll be here, but I won't necessarily be trying to teach a particular topic. It'll be more for you guys getting caught up on assignments that you didn't understand. So if you got a particular assignment and it's just not too bad, you can use that time to just get the work done with me in case you were stuck on something. Because the quarter's about to end. All right. Okay. So let me grab this. Let me guess, he lagged out again. All right. Let me stop this bell. Where did it go? I found you. Okay. All right, so that was the bell. Let me know. I got to continue on. It's 3:27. Now let me put the next part of notes, right? So we got the equivalent resistance. That's where in that circuit you have above, and this screenshot that you took or should have taken, all these resistors will be taken out and will be one resistor put in place to replace all those resistors. That's essentially all the equivalent resistor is. Now in a series circuit, you add them together. We did that, but we are missing R3. So we have to find, put it in your unknowns over here, right? You gotta find R3 and its own value, and REQ and its ohmic value. And then you have to find in part B, just recapping real quick before we get too off track, all the voltage drops across each resistor. So when like the light bulb, when the current hits that bulb, how much voltage is created? And it's 3 resistors, right? So we did some algebra. We crossed out terms using Ohm's law here. It's another way to write it. V equals I times REQ. Okay, it's just a little bit more advanced version of Ohm's law. Next, we said, all right, voltage divided by current is what we need because to get this current detached from the REQ using algebra, we're going to divide by current to cancel out current. So cross it out and we get REQ. We put our numbers in from earlier. volts and amps cross out, you get ohms. And this is our REQ we're going to use to get R3. All right, I just want to explain all that. So the next set of notes you'll notice, let me make sure you see it, is this. Let's put this in the chat. All right, so I'm going to give you guys approximately 3 minutes to make sure you edit these set of notes correctly, okay? Let me scroll up or scroll down, but the major points is, like, you got a 2 here. You got to change that, all right? So those are all subscripted. Then there are things that are crossed out. What you'll notice here is you got to cross some things out here and it won't exactly show you in the chat. So what crosses out here? Well, we got R1 and R2 negative and R1, R2 positive. That automatically crosses out. And so is this value. So you know how exactly we got the equation. And all those steps have to be pretty much edited the same way. Okay, so now you see what's happening here. The algebra in this part really occurred in this step. If you don't remember last week what happened, right? So there's a change in the steps. So the small things that you have to have understood when you're editing your document. All right, so how about what I said? It's 3:30 now, about 2 more minutes on that. And then we're going to go through the last part of the notes. We're going to try to do a share out. And that'll be it for today, right? So 2 minutes. You just got to edit those notes the same way I did. Don't forget, there are things that cross out that the chat won't show you crossed out because it's a format thing, right? And this is just basically part A. I haven't given you the steps of part B. And all I did there was some algebra to get REQ by itself after we found what REQ was. Use the equivalent resistance calculation to solve for R3, third resistor. All right, so now it's time for the last segment of notes. Is 333. Wow, it's a mystical number. About time to get out of here. So last part of notes, that's your voltage drops, right? So across each resistor, how much voltage is present? That's all that's being asked. So let's grab this and finish off everything, right? And if we don't have time for share outs, we can do it tomorrow at the start of class to see who can get points. All you gotta do is just show how much of this assignment you got done tomorrow. So here's the next set of notes. And yeah, some edits in there you gotta do, right? Let's take a look at this. Right? So amps crosses out with ohms and gives you volts. That's only when it's multiplied. This is following the equation for B equals IR. Notice this is the voltage drop 1, which is equivalent to the current, which stays the same, in all resistors of, and the current's multiplied by R1. Now, if you go to the second voltage drop, and you got to calculate it down and stuff to get the final answer for that first V1. V2 is going to be V2, right? The voltage of V2 is going to be created by the current again multiplied by R2, right? So make sure you edit it the same. And then in this step, it crosses out, just showing you the edits you need to be aware of. Remember again, ohms and amps got to cross out. So this is amps, but that ohm should be an omega symbol in that one too. Let me fix that. Cross this out. I'm just showing you guys where you have to fix it as far as your formatting in the chat. Now these ohms are these symbols here, right? Remember, everywhere you see ohms, you're going to put this. Not about Ohm's law, I'm talking about as far as our calculations. Just come over here and clean that up. But you got to do that to V3 as well, okay? But let's see, it's 3:35. Does anyone feel confident in sharing out what they have so far? Now, this is for in-class points, but if you need time, you can use this time to catch up. Otherwise, if you share, you might be able to leave a little bit early. I mean, not too much early. It's 3:36. You have 4 more minutes of class. So use this time to finish up your document if you can. That would be wise, right? And I'm just subscripting all of these, right? Now this one crosses out. Format text. And then we'll cross that out. This is supposed to be omega, right? And so is other. I want to cross out too. So this is this. And this is this. There we go. And I think this one crosses out with the other one, like it did earlier. Yep. And don't forget about this one. Right. So this amps doesn't cross out here. It crosses out in the next step. There we go. Better. Way better. You cross out though. All right. All right. So it's 3:37. You guys got any questions for me? I'm just finishing off the edits. I'm just showing you what you have to do. That's all I'm doing. Okay. Okay, so Autumn, can you share your screen? I see you guys are just sitting there. Are y'all typing? It's hard to see what you're doing. You getting what I'm giving you or no? Jalen, Kennard, what are you guys doing over there?
I can do math.
All right, go ahead.
But the button not here.
The button's not there? Oh, let me put the button back. You're right. Thank you. Okay. How about now?
Yeah.
And then turn on the chat for you guys. There you go. Oh, you got a lot done. Way to go. You got it all. Just do your edits and try that second problem for homework. I mean, okay. I'll see you tomorrow. Great job. Turn it in tonight if you can by 8. Autumn, what about you? Jalen, what about you? You guys ready to share? Y'all quiet on me. Okay, autumn sharing. All right. Oh wow. Okay. Okay, you were crossing stuff out. You still working on it. Okay. Okay, so continue working on it. Get it all done by 8 p.m. Autumn. I saw it. Make sure you turn it in. All right. Okay.
Okay. All right.
Jalen, sir, what have you? Can you share your screen? There you go. Okay. Okay. So you're trying to add. Oh, okay. You're doing certain things. Okay, but it's like you got most of the notes. Can you scroll down some? Okay. Uh-huh.
I have to I'd separate this,
Oh
but
yeah. Yeah. Okay.
but yeah.
Okay. Okay. You gotta do the edits, right? Yeah. Okay. You working with it? Okay. Make sure you turn that in though. Okay. When you get
Uh,
done, then try the second problem.
I need the link to that. What's the name? The
The link.
the
The link to what?
simulation.
Oh, the simulation.
Yeah,
You have open up your open. I can show you faster. You have my slide open. Yep.
yeah,
Okay. Click on that yellow box. Okay. Click on me. You see SPS there? All right. Come over to the circuit. You see right by the duct. Oh, you pass it up. Come down. Come down. All the way at the bottom. That one. Okay. And you're gonna go to lab. Awesome. Yeah, click on it, and that's how you do that.
okay,
Okay. You know how to take the screenshot, right?
yeah,
Okay. All right. You got till 8 p.m. to turn it in, dude. I'll see you later.
okay.